All right. Now, we did part of this section at the very beginning of this week. We talked about negative exponents already, and I said negative exponents cannot be left in your answer, right? But I said there was an exception. And the exception is what we have right here with scientific notation. Now, scientific notation, if you've ever taken biology or chemistry, we have to, or even physics, we use scientific notation to express really large or really small numbers, okay? So this is used to express very large or small numbers. We use this to express very large or small numbers, okay? And the form that it takes is going to be a number times a power of 10. We use the decimal system, don't we? Every place that you move in a number is another power of 10, right? Well, the m is just going to represent a number that's less than 10 but greater than or equal to 1. It's some decimal between 1 and 10.
Shouldn't it be an n, not an m?
I use my little n here for the exponent. This is just the typical way we have for writing this. N is going to be an integer. Remember, integers are those positive and negative whole numbers. Okay, the guys that you like to work with. Okay. Now, an example of scientific notation is something like this: 1.7 times 10 to the negative 15th. And you may see something like this when we're talking about measuring the size of of an atom or the mass of an electron, or you're talking about things that are on the cellular level. Okay. It's a very, very small number. And the reason I know it's small is because of this negative exponent right here. A negative power of 10 means a very, very small number. Okay? And let me show you what this number means. You're going to see why scientific notation is so awesome. If I were to write this number out, it would look like this.
0, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5.
That's the number. Oh, you weren't keeping track as I was writing the zeros? Now, my decimal is right here, but in the original number it was right here. How many decimal places do you think that is? That's 15 decimal places. Okay. When you have a number that's a negative like this, it's a very, very small number. Okay? If you don't believe me, what if I told you that I would give you this much money every day for the rest of your life?
Look for another job.
What if I told you I'd give this to you every second of the rest of your life?
Not retired.
You retired?
You said, I'm sorry, you said what?
If I gave you this much money every second for the rest of your life.
But it's a negative.
It's not a negative number. The negative power means a small, small number. If you took this, and suppose I said you were going to live 100 more years. If I did this for 100 years, so that means 100 years times 365.25 days per year times 24 hours in a day times 60 minutes in an hour times 60 seconds in a 60 seconds in a minute. Years cancel, days cancel, hours cancel, minutes cancel. So if this is how many seconds you'd have in 100 years. If I took that and multiplied that number together, I'm going to crunch that number real quick so you guys can see. So that's 1.7 to the negative, I said 15th, times 10 to the negative 15th. So times 100 years, times 365.25 days in a year, times 24 hours in a day times 60 minutes in an hour times 60 seconds in a minute. So if I gave you this much money every second, and you could live 100 more years, that means I would owe you this much money. I would owe you that much money. Tell you what, do you mind if I go and give that to you now? Then maybe you can invest this. This is nothing, right? Here, I don't even have a penny. I can't even round up to a penny. All right? So you see, it's a nice way of writing a very small number. Because do you want to write all those zeros out? No, because writing all these zeros out is very much like that student that we made fun of the other day when they wrote all those X's out and you go, LOL, right? Because if you write out all those zeros, you know what's probably going to happen? You're going to lose track of them. And you're going to have to be counting them over and over and over again, and it's ridiculous, so don't do that. Now, I could give you an example of something like this. 2.52 times 10 to the 8th. Do you think that's going to be a large or a small number? What makes you think it's going to be a large number? It's a positive power of 10, right? If you were to write this out, it would be the following number. Well, which way would you move your decimal to create a large number? To the right. So if it starts right here, that's 1, 2. How many more places do I need? 3, 4, 5, 6, 7, 8. So that's what that number really means. Now, if you're not sure if that means a large or a small number, let me do this. Now it's a large number, right? That number looks familiar, right? That's how much some people can get paid in 10 years if they play baseball really well, Alex Rodriguez. Even if you're not actually on the field, you can still get paid. I'm in the wrong profession, right?
You're still moving the decimal to the right regardless.
Well, no.
If it's negative.
Because up here, to go from this number to this real decimal, I had to take this guy and I had to move it 15 places to the left. What you need to understand is that it's a 15 decimal place difference. You just have to make sure you move it in a way that makes sense. Like we were already talking about. A negative power is a tiny number. A positive power can be a large number. Right? And let me show you how we go, if we want to go backwards here. If I gave you this and I said, here's this number and I want you to write in scientific notation. Okay?
I'm not even going to try.
You're not even going to try.
I don't want to try writing it back down and I have to count. Anyway. Oh, I still have to count it anyway.
You still have to count it anyway. Now, I need to move my decimal from right here. Where does it need to go? Because I'm trying to create a decimal between 1 and 10. Where does it go?
After the 8.
Has to go right here, right?
Right.
So I know that my answer in scientific notation is 8.09
Times 10 minus 10.
times 10 to the what power?
11.
Negative 10.
There are 10 zeros that I have to go past, right? So this would be to 10, one more is 11, so that's negative 11. Do y'all agree?
Mm-hmm.
Why is it a negative power?
Because you're going back.
Because it's a small number, right?
Yes.
Again, if you don't know if it's large or small, put a dollar sign in front of it. If it gets you excited, that's a positive power of 10. If it means like whoop-de-doo, it's a negative power of 10, right?
11.
Huh?
Negative 11.
Let's do one more. Is this a big or a small number? That's a pretty big number, right? Nope. Where is the decimal?
9.20.
It's right here. Where does it need to go?
After the
needs to go right there. So how many decimal places is that? That's 12 decimal places. Now notice whenever I do my multiplication symbol, I'm using what's called a St. Andrew's cross. Okay? Do not do a raised dot. If you do a raised dot, that could be confused with your decimal that you have here if you don't put it in the right spot. So do it like this. Notice this is not my x. Okay? As you've seen before, that's my variable x. That's my multiplication x. Make sure that you do write things correctly. Don't get so sloppy that your multiplication turns into a letter. Now this number right here is 9.2 trillion. That looks like a really big number, right? Well, that's about half the national debt.